Hi everyone, this is Nono, and this is an introductory tutorial to SketchRNN and how to use it as an HTTP service. So what we're gonna see in this tutorial is what SketchRNN is, the structure of the vector strokes that are used on the architecture of this neural network. This means what information we need to feed the neural network and what information we're gonna get. How do we define the drawing that we input and how the output drawing is usually defined. Then we're gonna see how to run SketchRNN as a service, for which we're gonna use Node.js and JavaScript mainly. And then we're gonna see how to request a drawing prediction from JavaScript. So SketchRNN is a recurrent neural network able to construct stroke-based drawings of common objects, which was part of research work that Google did in early 2017. They trained on thousands of human drawing images that represented hundreds of classes, among which you're gonna find, for example, bird or bicycle or angel, sofa, a lot of them. And some of the models are actually 3 megabytes and some others are 11 megabytes. This makes a difference on the time they take to execute, but for our purposes, we're just gonna have those different models embedded as a JSON file. The particularity of this framework is that it allowed for conditional and unconditional sketch generation, and more importantly, it has robust training methods to generate sketch drawings in vector format. There are other well-known neural networks called generative adversarial networks like Pix2Pix that also have been able to generate things like drawings or textures, but they're usually based on image to image mapping. So everything was raster, but here the importance is that we can use vector drawings, vector information. Here are some examples that I ran with the Verde model. So we can see that SketchRNN is actually continuing a drawing and drawing different continuations of what I think a bird should look like by starting from an input drawing. For example, here the input was the middle square and it tries to find the bird. And what you're gonna find in these generative models, anything that you give to it, it's going to try to make sense of it and find whether it looks like some part of a bird or not. I mean, it's not gonna know how to do anything else unless you tell the neural network to use a different model. So if we wanted to draw a bicycle, we have to right now expressly tell the neural network to use the bicycle model. Here we're using the birds, as you can see. Even though we're trying to write as G, we get to sort of two birds. This is a different test that we did. The tests before were with a P5 JavaScript client. This is running in processing, this one here. And the only thing that we can see here is that from one same input, the neural network will return different outputs, different times that you request them. As I mentioned before, Stroke has a specific syntax, and this is an example of an array of points. I don't know, I mean, they're not exactly called points, they're just information that we're gonna see right now what they mean. They have each of the points or the members of this stroke have 5 elements: delta x, delta y, and then p1, p2, and p3. Delta x is the direction of the pen from the previous point, so the difference in x coordinate. Delta y is the same but in the y direction. And then we have the other 3 elements that represent a one hot vector. This is a vector that can be either 1, 0, 0, 0, 1, 0, and 0, 0, 1. And depending on what we get or at what part of the drawing, it's gonna mean one thing. 1, 0, 0 is gonna mean that the pen is currently touching the paper and that we will be drawing a line to connect to the next point. P2 being 1 means that we're gonna lift the pen, so that we're gonna end one stroke to continue another, but at this point we're not gonna draw, so we're gonna move to a new start point of another line. And then P3 being 1 means that the drawing has ended and that we're not gonna draw anything else. Basically the P1 is used when you're gonna start a line. P2 is when you're gonna switch from the end of a line to the start of another line or polyline. And then P3 is for when the drawing basically has ended. And just to note, this is not something we need to worry excessively, but I mean, on the part of the code, when we want to draw things and construct the input for the neural network, we need to have it in account. So for the demo on this part, on SketchRNN, we're gonna see, as we said before, how to run SketchRNN as an HTTP service, and then how to request drawing predictions from the browser and from JavaScript in code in Node.js. So let's get going with the HTTP server that uses Express. We're gonna see a server that we have already built that makes get and post routes that you can later call from curl commands or from the browser, from Node.js, or from any other platform around the internet. The server for now, we're gonna run it locally, but it could be served online on a website like Heroku as a Node application. And then also noting that the cross-origin requests need to be activated, because when you're running locally, sometimes the browser or different applications won't allow you to make requests to an endpoint, to a URL that is not the same that the one you're using. So let's get started. What we can see here, this is the Smart Geometry repository, a work in progress repository with different neural networks and machine learning projects that we've crafted for being used as a service. And we can see that SketchRNN is available in HTTP, WebSockets, and JavaScript, and that we also have a folder with all the models. Just to note first what I said before, that we have like 100 models or so. We have all the models here, so just by dragging them to the lib folder, you're gonna be able to use any of them. Right now, we have the bird by default, but this HTTP service that we're gonna use accepts a parameter that's called model, and you could send the string of what models you want to use. If we open the SketchRNN folder that we will provide with this video, we can see that what we're gonna use is the HTTP server. But first I wanna show you the libs, the dependencies that this project is using that are particular to SketchRNN. One of them is the SketchRNN.js, which is a file developed by the people who wrote the paper, David Ha and from Google Brain. And we've done minimal edits here to make it work as a JavaScript model. But this has all the information for how the machine learning algorithm generates a prediction from an input drawing. What we've done is build a smaller model in JavaScript that contains everything you actually need to interact with to provide a model with an input, so it can generate an output for you, and everything is handled. But you can, I mean, if you're curious, you can browse the code. The only method that we care about mainly is the predict method. So let's dive into the code of the HTTP server and let's run it to see how it works. So even without looking at the code or anything, we can start by running the HTTP server by writing node HTTP server.js on the folder that this file is contained. Well, if you're cloning the project right now, you can see that there is a package.json file and all the other dependencies, but you probably won't have node models, so you have to do npm install first for node to install all the required packages. So after you've done that, we can actually run the server. So you can see that the server started at localhost 8080, but nothing really happens yet. If we open the code of this server, what we can find is that we have some setup at the beginning. We're doing is loading express, that is the node library that allows us to easily create an HTTP server. We have body parser to be able to parse some parameters on the get and post requests. And then we have some configuration of the port, and also what I mentioned before, the coarse or cross origin request. So we allow a wildcard of the origin. So we allow requests from different domains than the domain that the server is run at. So if we forget a bit about the setup, the important part here is that we're loading a simple predict, the simple predict model that we have wrapped SketchRNN in, and then we are exposing 3 different routes, 2 post routes and 1 get route. If we look first at the get route, which is simple predict, we can see the code here. But let's first actually make a call to this. So what we can do is that we can copy this example URL, as you can see is localhost 8080 simple predict, and then it's passing a parameter on the URL with one of those strokes that I explained before. It's basically having the delta x, the delta y, and then the one hot vector here. So we can go to our browser, open a new tab, and then load this website. What's happening here is that this get route is getting this stroke as an input, and it's providing this as a response. And this is an actual drawing prediction. We can update this page and we will get different predictions. If we were to draw this in one of the P5 or processing viewers that we have, we will see that this is actually a drawing of a bird, starting by this simple input. But this is not too interesting yet. So what's happening here is that we are getting the strokes parameter from the URL with this line here, and if that variable exists, we are actually setting the strokes to that value that we're providing on the URL, and then we're calling the predict method that I mentioned before from the simple predict model. What happens here is that we provide an input that might be a circle, a square, or like some other set of lines that we have drawn in an application, and then simple predict calls a predict method that calls SketchRNN and generates a prediction of the drawing based on 2 things: the model that you have selected, that here is bird by default, but you could have changed it, and then the input drawing that you've done. After predicting, we just grab the output strokes that SketchRNN has generated and output them on the HTTP request as JSON, and that's what we're seeing here. This is a JSON array of strokes, and there is not too much more to look at here, but what is interesting is that on the post side, that is the one that is actually meant to use with other applications, we have simple predict and simple predict absolute. What we've done here is that simple predict actually handles whether simple predict has the strokes in this relative mode, or if you're actually providing them in absolute coordinates. That would be, instead of giving the delta x and delta y, you would be giving the actual coordinates that the sketch has been drawn in an application like p-file processing. If we take a look at simple predict absolute, that is the route that we're actually using in other of the examples, you can see that we have added also here a conditional for changing the model. So if you pass the model argument in the post request, we're going to try to load that model from the folder of the models. And just to show where those models live right now, you can see that on the lib folder that we had before, if we go to models, here I have some models downloaded, and I would be able to pass any of this in my post request, and then SketchRNN will change, load this model to draw with different predictions. And everything that happens afterwards is exactly the same that we saw before. We set the strokes, and then we predict, and then we output them as JSON. So what is more interesting here that we can see? So we've seen what the HTTP server with Express looks like and how we can make a GET request with the browser. But now we're going to see how to make a POST request with something like Super Agent or even a raw AJAX POST request. So we have provided also a P5 client that is available in both HTTP or WebSockets, but we're gonna open the HTTP right now. So this P5 client runs also on the browser, and what we have is an index.html and then a P5 sketch. So if we open this file, what's going to happen here, and I'm going to go to the code first so you can see. Well, let's make a test first, and then we'll see the code. So we what we didn't see before, that I should have shown you before, is that every time you make a GET request here on the browser, you get some information here on the console. So if I load this page again, you can see that the server is actually receiving the input stroke, and then is processing it with certain parameters, and is loading the bird model, and then is outputting it to the browser. And as we call more times, we can see that the server is actually processing information. We can also see that if we use a P5 client, where we can, for instance, draw a circle, and then we will get a prediction real time and then draw it here. By pressing Command or Control X, we can remove, and then we can keep drawing things to get more predictions. And this is, I mean, this is the basic concept behind this, right? What we've done is embed something that was out there, that was a SketchRNN, modified a bit to wrap it on a simple node model, JavaScript model, and convert it into an HTTP service, so it can be used in an interactive application like this one in P5 as an input-output HTTP service, which could be also hosted on the cloud in something like Heroku, like I commented before, or it could be even running on your computer, and we could tunnel it through the internet for somebody else to use it and executing things on your computer. I'm just gonna do this really quickly because it's really easy. So if you have ngrok installed, you could install ngrok by running brew install ngrok, or looking how to install it on Windows. I don't know exactly how to do that right now, but we could expose or tunnel this URL of our computer, localhost 8080, to the internet, and anyone would be able to access this in my computer right now. If if they type this URL on the browser, right? So if I replace this here, you can see that the request is still coming and the server is executing, and we're getting a response here. And that would mean that you would be able to have a client on the internet that is sending requests to your HTTP service on your local machine. And I think this is all that we had to see. We were gonna see the post request with super agent, but what we have on the code at the moment is a normal HTTP Ajax call. Here, where is this? Yeah, so if you look at this code would be what we would call a post request from the P5 side, and this is something that you can do in any website in JavaScript to make asynchronous calls to other APIs. And in the HTTP tutorial, I show how to interact, for example, with GitHub's API, and you could interact with other services and other APIs. What we could do here is that we're passing the strokes as a parameter, and we could pass a model name as a parameter. So we could have here, let's see what models we have in the folder. Okay. So I have lobster, hedgehog, angel, duck, and bird. So let's try with lobster. Lobster. Let me see. Okay, so I've actually cheated a bit. I stopped the video because I remembered that we had a more updated version that is not the one that I was running. And this version actually handles the JSON model, so you can pipe all the models that I showed before. And I added this feature where we have the variable model name in the P5 sketch. So by default, that variable is going to be bird, but as you can see, it's dynamically passed through the post request to the server with the sketch input. This means that right now the server is always getting a request for a bird sketch, but if we see on the console, model name is bird, and we can directly change this variable to lobster, for instance, and directly we can draw something different, and the server will load that model for us, which is pretty cool. Well, that worked really well. So sometimes we're gonna find that we're gonna draw things and the server is not going to really so the sketch-rnn is not going to really give us something that looks good, and this is usually because the way you have drawn the input sketch is not the way that another person on the training set would have drawn it, or because the input sketch has too many points and it doesn't interpret it properly. So behind the scenes, I have also downloaded other models. So what I'm gonna do here is that we're gonna try a few more, and then we will be done with this tutorial. Let's try brain. So as I mentioned before, some of the models, instead of 3 megabytes, are 11 megabytes, and those actually take a lot longer to generate a prediction. Yeah, I don't know how to draw a brain, apparently. Well, let's try with hedgehog. Nice. We can try cactus. So part of the time that SketchRNN takes sometimes is to load a new model, because some of the models are really big, and then the biggest the model size, the more it's going to take to generate an inference, to generate an output. Okay, let's try duck. We also have one that usually works pretty well. Duck works pretty well. Let's try bicycle. Kind of. And let's try angel. Cool. Nice. Okay, I'm gonna actually try bridge just because I'm curious to see. Meh. Nice. Well, I didn't want to go a lot longer with this. I just wanted to play a bit more and see like how easy it is to download more models and play a bit with them. So I encourage you to try these things by yourself and see if you can maybe make a different interaction with it, a different interactive application, or some other use of it that you think that is useful or can be cool. And just think about it. We have different ways to use it. We have WebSockets, we have HTTP, we have a standalone JavaScript library. And the purpose of this is that you can use it from JavaScript. I know there's also some native Python code of the original TensorFlow development of sketch-rnn, but the capability that the HTTP server and the WebSocket server give you is that you can use it from any language. You can use it from Python, you can use it from Go, from the command line, from the web, basically any platform that supports HTTP requests. Well, so that was it. This was a brief overview on SketchRNN. We are Nono Martinez Alonso, Nono Espa on Twitter, and Jose Luis García del Castillo y López, García del Cast on Twitter. Feel free to send us any questions or ideas that you might have. And as you can see here, we've generated a lot of GIFs, and we are, because we really like GIFs. So we'll be releasing also a tool to export those P5.js drawings to SVG and then automate the creation of GIFs with another P5 sketch. Thanks so much for watching, and I hope it was useful for you to learn a bit. Bye.